Hi, welcome to the next lesson, 3.7. This is a follow-up to the Pythagorean theorem lesson called the distance formula. It's a really similar concept, so let's get into it. Basic idea is we're going to put 2 points on a graph, and we want to know the distance. The distance between 2 points is a straight line. So here's 2 points on the graph, 1, 2, and 7, 5. And the question is, how long is this blue line segment? Well, one thing we can do is consider this imaginary triangle that's formed. And we have a right triangle. There's our right angle. And so we're just calculating the hypotenuse of this right triangle. To do that, we need the lengths of the two sides. So from this 1 to this 7 is 6 units. So the length of this side is 6. And then from this 2 y value to this is 5. It's 3 units, and you can count them. There's 1, 2, 3. You can just count them. So there's 3 units. And now we're just doing the Pythagorean theorem. 3 squared plus 6 squared is c squared. Square those out, add them up, take the square root of both sides, and we get 6.7, which is a little longer than this side, but it's the longest side, so that checks out. The distance formula is basically just putting a formula around this process. So if we generically think about a point x1, y1, and the other point as x2, y2, then the horizontal distance is just the difference of the two x parts of the coordinates, and the vertical distance is just the difference of the y parts of the coordinates. And so to get c squared, we're going to take the horizontal distance. We could call that a if you want. That distance is a. The vertical distance, we could call that b if you want. And it's just the Pythagorean theorem. And then to make it a little simpler, we're going to square root both sides and rearrange it. And so this is the distance formula for 2 points on a coordinate system. You can always use the Pythagorean theorem if you'd rather. This is just the same thing. So I'd probably write that down in your notebook or something right now, because we're going to use it. All right. So here's how we use it. Here's 2 points, and we want to find the distance between the 2 points. So we just plug it in. Okay. I will point out, it doesn't matter which point you label as point 1 and point 2. Because what will happen is you'll get either a positive number or a negative number, and then when it gets squared, it will be the same thing. So you pick one to be 0.1 and one to be 0.2, and then plug the numbers into the formula. So here we have, let's just rewrite the formula, I guess. So this is x2, and this is x1. So that's how we got this part of it. Let's fix that. Okay, and then for the y ones, this is y2, this is y1. That's how we got this part of it. And then we'll just keep going. Subtract 5 minus 2 is 3, 1 minus 7 is negative 6. So note the parentheses here. You're going to, whatever this whole thing is, we're going to square the whole thing. So it's okay, we got a negative number. That's okay. 1 minus 7 is negative 6, and then we'll square the whole thing, negative 6, to become positive 36. So 3 squared is 9, negative 6 squared is 36. And now you just add those up and then take the square root in a calculator, 6.7. Next example. Okay, there is x2, and we're going to subtract that one, negative 3. So 6 minus negative 3, all squared. So that's 9. If you think about it, these two numbers are 9 squares apart on a grid. It takes you 6 to get to 0 and 3 more to get to negative 3. And then our y values, negative 1 minus 4, all squared. And these are 5 units apart. And so when you follow through the formula, these x pieces being 9 apart get you to 9 squared. These y pieces being 5 units apart gets us negative 5 squared. Doesn't matter if you get negative or positive. If you switch the order, then the signs will just switch. But once you get this far, the negatives don't matter. So this should always be plus when you're doing these, because the negative, if there is a negative, when you square it, it'll be positive. You add them, square it in a calculator, and you're done. Last one, there's x, negative 5 minus negative 2, all squared. And then the y is negative 10 minus negative 3, all squared. And then these are 3 units apart. These are 7 units apart. Then we square them, add them up, square root it in a calculator, and we're done. Okay. A couple application examples. So we've got here a map of a skate park, and they are putting a grid on top to help plan this out and reference the locations. They're going to put a half pipe in, that's cool, at the coordinate negative 5, 7, and a handrail at coordinate 2, 1. And the grid map, 1 square maps to 10 feet in real life. So we want to know the distance between the half pipe and the handrail. So we're going to use the distance formula. We have 2 coordinates and we were asked to find distance. So that's our clues that we're going to use that distance formula. You could draw a picture, it would be helpful. You don't need to put all this level of detail into it. You just need to know where your 2 points are. So there's our 2 points, and this is the distance. Purple line is the distance. Well, this is just the distance formula. Or you could do the Pythagorean theorem and just count. It's the same thing. So we have 2 minus negative 5 all squared. So that means this horizontal distance is 7. And then the vertical distance, or we have 1 minus 7 all squared, which means this vertical distance, if you think about it, it is 6. So 7 squared plus 6 squared. If we were doing the Pythagorean theorem, we would get to the same spot. Anyways, either way, distance formula, Pythagorean theorem, add them up, square root, and we get that this is actually 9.22. It's like grid squares or units, but that's not super helpful because we want feet. So then we convert back to feet, and there each square, each unit is worth 10 feet, so it's 92.2 feet. Next one. This is a real one. So Spring City is northeast of Ephraim. Here's a map. And you take roads to get there, but if you were to find the distance, that's basically the straightest line, or if you could fly it, then we're looking for this black length here. So Personally, I think the Pythagorean theorem is much easier on this problem. So how would that work? So it's 8.5 miles north and 5 miles east, and then we're just finding c in the Pythagorean theorem. But let's go ahead with this one. What we could do instead is label it as a grid. So Ephraim would be at 0, 0. Spring City would be at 5, 8.5. And then we could use our distance formula. So yeah, there's our x distance, which is 5. That's there. And our y minus y squared is there. Calculate it out, and it's 9.86 miles. But really, this is just Pythagorean theorem. So that's it for the lesson.